Right, in this video we're going to look at intersecting chords. So we've got the chord A, B and C, D, but they intersect outside of the circle. So it says chords A, B and C, D intersect outside the circle. C, P, C to P is 8, DP, DP is 6, and then AB is 8. Find the value of AP, it says. Okay, so for chords that intersect outside the circle, the same formula applies as when they do intersect inside the circle, that AP times BP is equal to CP times DP. So CP is 8, so we're going to annotate our diagram here. Now the diagram's not to scale, so don't get put off by the scale. So this is 8, DP is 6, and AB is 8. This distance here, AB, is 8. So that if we let this distance here, AP, be x, and then using this formula, we can say that x, which is AP, and now BP is going to be x plus 8, is got to be equal to CP, which is 8, times DP, which is 6. If we now expand that, x times x, we get, let's just put the raw in, AP, BP, CP, DP. Pause the video and just check that we have the right things here. So we now need to solve this equation. So expanding the brackets, we get x squared plus 8x is equal to 48. This is a quadratic, so in order to solve a quadratic, we need to put it equal to 0. So we've got x squared plus 8x minus 48 is equal to 0. So either use the product sum factors method, or we can look at x and x. Two numbers which multiply together and make 48 are 4 and 12. But there are quite a few others. But if we did 12 minus 4, we get 8. So if I make that minus 4 and plus 12, and then minus 4 times plus 12 also makes minus 48. So then we can say either x minus 4 is equal to 0, which gives that x is equal to 4, or x plus 12 is equal to 0, which gives x is minus 12. Now we can't have a negative length in this context, so not possible, and therefore AP will be equal to 4 only. So this has been a video to show how to find a length using intersecting chords which intersect outside of the circle. I hope you've understood, and I thank you very much for watching.